So today's lecture is about integration of rational functions by partial fractions. I would like to begin with the following problem. Integral of 1 over 1 minus x squared. Okay, so you're familiar with this problem. There is a formula there, even, right? And we did it several times. This is the integral, the antiderivative of this will be the hyperbolic tangent x. Okay, so we do have a formula for that. I'm not going to use the known results to solve the problem. So what I'm going to do is I'm going to use the following property. The integral of 1 over x minus k dx will be the natural log of absolute of x minus k, okay? And the plus constant. That's easy, right? So if you shouldn't know how to get this, right? It's just you can use substitution. Yeah, you get integral of 1 over u du, then that's going to be a natural log of absolute of u plus constant c. So how to modify this? Okay, this is going to be 1 minus x times 1 plus x. But I find out I can separate this. Okay, if I add them together, I get the numerator 2. So I have to divide by 2. Yeah. This is a 1 plus x plus 1 minus x. Is 2 is left. X canceled out in the numerator. So you express this product as a sum of 2 terms. Okay? And you can also express it in the following form minus. I'm going to put the x first. Okay? Because I want to use the above formula x plus 1, x minus 1 plus constant. It's the same. But I put a negative sign. If we switch x minus 1 minus x becomes x minus 1, I put a negative sign in front of that. So then the integral of this function is going to be the integral of 1 over x plus 1 minus 1 over x minus 1 and dx. Okay? Then I can evaluate the integral. Absolute of x plus 1 minus, right? Then I can combine them together. Okay, plus constant. Okay. I can also, this is a no restriction on x here. Okay, x plus 1, x minus 1. Well, it's not going to be 0. Okay, so this is true when x is not going to be plus or minus 1. Because when x is equal to 1, then the denominator is not defined. When x equals negative 1, the numerator is going to be 0. So natural log of 0 is not defined. Okay, so you can, now what happens when absolute x is less than 1? When the absolute value of x less than 1, actually, I change this back to here, right? I want to remove the absolute value symbol. This is a true when if absolute x is less than 1. Because if absolute x is less than 1, then both the numerator and denominator are positive. That's why you can remove this. Okay, and it's surprise. This is nothing but the inverse hyperbolic tangent x. Okay, and see page 487. That's the formula. In other words, we do have a now then I record the formula, right? So the derivative of hyperbolic, the inverse hyperbolic tangent x is going to be 1 minus x squared, right? This is on page 488. Okay. Yeah. So if you know this, definitely you have no problem. Just integrate it. Okay. 1 over 1 minus x squared. Yeah. So let's take a look at next problem. Okay. So it's the integral of 2x minus x squared and dx. Okay. So this looks similar to the above one, but I cannot easily decompose it as two functions. There's a sum of two nice functions. So how do you solve this problem? Well, x squared minus 2x, right, can be written in the form, you can add 1 minus 1, right? Yeah, x squared minus 2x equal that. So it's going to be x minus 1 squared minus 1. So the integral of 1 over 2x minus x squared, there are many ways to solve this problem. And this will be the negative of that. So it's minus x minus 1 dx. So you know what is next step. Use substitution. Okay? So you let u to be x minus 1, then du equals dx, right? So the integral becomes 1 minus u squared du. And we go back to that form. It's half of natural log, 1 plus u over 1 minus u, right? And plus constant. Right? So 1 plus u is going to be x. 1 minus u is going to be what? 1 minus u is going to be 2 minus x and plus constant. Okay? So if you are able to, you see the quadratic function in the denominator, you can always express it in this form, okay? So a quadratic function, any quadratic function, a x squared plus bx plus c can be written in this form, okay? It can always be written in this form. Because sometimes you have, let's do this problem. As long as you can do these two problems, you can do all the problems when there is a quadratic function in the denominator. So what is this? Do you remember that? The antiderivative of 1 over 1 plus x squared. What is the antiderivative? This is going to be arctangent. No, just not hyperbolic. 1 over 1 minus x squared is the inverse of hyperbolic tangent. This is the inverse of tangent x. Okay. So now, you cannot make any change there. So now, if I give you an arbitrary function, I just randomly write down, okay? I can say x squared minus 3x plus 2, okay? It's random. How can I evaluate this integral? Okay. I have to express this in the standard form. So that's going to be how to complete a square. So x squared minus 3x, right? You have to add the number, subtract a number, okay? And then you can combine them like x minus 3 over 2 squared minus 3 over 2 squared. Okay? So the integral, okay, so the integral becomes x minus 3 over 2 squared minus 3 over 2 squared. Yeah. Okay? So what kind of substitution I'm going to use? I can let u to be x minus 3 over 2. But maybe I have to also put the 3 over 2 divide by 2 over 3. Yeah. Okay. Yeah, maybe it's divided by 2 over 3. Yeah. So if you use that, it would help you a lot. So du equals 2 over 3 dx. Okay. Then the integral becomes 3 over 2 u square minus 3 over 2 square. So I can take so 3 over 2. Okay. I can take the 3 over 2 out. Yeah, dx is going to be 3 over 2. Du. Okay. X minus 3 over 2 is going to be 3 over 2 times u. So that's why you can take the same fact out, right? So now what do you get? You get 3 over 2 taken out. It's going to be 3 over 2, right? And integral of u square minus 1 du. But this is the same like 1 minus u square. I can switch the order. So you will get this. And natural log, remember 1 plus u of 1 minus u. If you're not sure the absolute value, then you're not sure u is large or small, you put the absolute value on it. All right, so my final answer is going to be 1/3 natural log 1 plus u. What is u? U is 1 plus u is 2 over 3 x minus 3 over 2. And here 1 minus plus constant. So you have to simplify a little bit. I got 1. I cancel the 1. So it's going to be just 2 over 3 x. Then this will be 2 minus 2 over 3x and plus constant. Oh, wait a minute. Did I forgot 2 here. Forgot 2 here. So yeah, I don't make too much change here. I just forgot 2. Otherwise, yeah, this is what we got here. Okay. Then I evaluate this integral instead of the one I gave already. Okay. So that's why I begin with this. Okay. So this is the answer. Okay. And you can modify a little bit. And this is what we do. Now, there any other way we can solve the problem? Okay. There's another way you can solve the problem. So this is if you don't like the idea to complete in square, right? It's x squared minus 3x, right? So if you don't want to change it to the standard form, you can do the following. I can always guarantee you this can be separated into two forms. One is x, other one is x minus 3, but we don't know the constants yet. We have to figure out the constant, okay? And how do you determine the constant? You combine them again. It's going to be a x minus 3 plus b. Yeah, bx, yes. So you will get a plus b, x minus 3a. Okay. So in order to have a match in the both sides, so a plus b should be 0. Negative 3a is going to be 1. So now you from here get a equals negative 1/3. Then b equals negative a, so b is positive 1/3. Right? So the integral, it's not too bad if you can determine the constant. And a is a negative 1/3, integral of 1 of x. b is a positive 1/3, integral of x minus 3 dx. Okay? And then we got natural log of 3x plus 1/3 natural log of x minus 3. Okay? So this is the same answer as above. So there's two different ways to solve the problem. If the denominator, if the numerator is 1, denominator is quadratic function. Okay, let me show you another problem here. It is going to be it's going to be 3 minus 2 minus x squared. How about this, right? Okay. So 3 minus 2x minus x, if you take negative sign out, you get this. Okay? But you can factor this out. X minus x plus 3 and x minus 1, I think, right? Yes, 3x plus. So, use above idea. You will get negative, right? But I guarantee you, you can always express in that form. Right? Okay. So how do you do that? You combine them again. You get a x minus 1, b x plus 3. Here's x plus 3 and x minus 1. So you will get a plus b, here's x, and plus minus a plus 3b. Okay? Be careful about the sign. Okay, because the denominators are not matched yet. Okay, so clearly a plus b is definitely 0, but negative a plus 3b should be equal to now negative positive 1. It should be negative 1 because I don't have a negative sign in the denominator. Okay, so you have to put negative, you know, positive. Okay, if you write in this form, you will never make a mistake. Okay, so from here you can solve for b. Add them together. Add them together. You will get 4b equals negative 1. So b equals negative quarter. Then a is going to be negative b, so positive quarter. Okay. Right. So now you're going to get, you can get the integral. Okay. Dx. It's going to be, here's a quart x plus 3 dx. And this is going to be negative a quart x minus 1 dx. Okay. So you will get natural log of x plus 3 minus natural log of x minus 1. Yeah. Then you can also put them together. Okay. Another way to do is you still express it in the standard form. It's x squared minus 2 plus 2x minus 3, right? But that's not the standard form. The standard form is x plus 1 squared, here is minus 4. Okay? If you're able to get this, this is going to be 4 minus x plus 1 squared. Okay, so the integral becomes the question is what the substitution you use. If you use the substitution should be equal to x plus 1 should be equal to 2u. Okay, so x plus 1 because you want to take 4 out, so you can let x plus 1 to be 2u, right? Right. Then you have a 4, you take a 4 out, right? So dx equals 2 du. Right, so the integral becomes 4 minus 4u squared, and the dx is going to be 2 du. Okay, so you get take 1/2 out, and you get the well-known integral. This well-known integral, I still remember, is going to be 1/2 natural log. I put the first value here. Okay, so that's what I get. Right, so what is u? U is going to be half of, anyway, it's 1 plus 2 over x plus 1, 1 minus 2x, right? And you have to simplify. Simplified, you get 2 plus, yeah, it's x plus 3, and here's 2 minus x minus 1, it's 1 minus x, or x minus 1, doesn't matter. So this is answer. And let's compare what we got. X plus 3 is on the top, x minus 1 is at the bottom. Yeah, we get the same result. So it doesn't matter which way you do, you will get the same result. Okay? But if I modify the problem a little bit, the numerator, I'm going to increase, this is just 1, right? I put x plus 1 there. Then you have 3 minus 2 minus x squared dx. Or you can x plus 2. Really doesn't matter, right? So now there's a small change. The second method doesn't work here, right? Well, not exactly, but you still have to do some extra work. Okay, if you want to use a substitution and express it as an extended form, but you can do it in one step. It's a remember the factor, right? I forgot. What do we do here? Okay, the x plus 3x minus 1. Okay, x plus 3x minus 1. So get 2x, yeah, minus. Okay. For simplicity, I'm going to change it to negative x to negative 2, okay? So what I still can guarantee this can be decomposed to the following 2 terms. Okay. AB must be constant, but they're quite different terms. So I combine them. I will get a plus b x, and I think it's negative a plus 3b, the second part. Okay? Yeah, negative a 3b. So compare both sides. You will get a plus b equals negative 1. Negative a plus 3b equals negative 2. You're still able to determine the coefficient. Right? But if you want to complete the square in the denominator, it works. Yes, it takes a little bit more time. It's the same. You will get something like u plus some over 1 minus u. Right, so let's look at this equation. Add them together. 4b equals negative 3. So this time, b is going to be negative 3 over 4. Right? And a is not going to be negative b. A is going to be negative 1 minus b. And then negative 1 plus 3 over. So it's negative quarter. So those two are different constants. Right? So now we are ready to evaluate integral. So that is going to be the constant a negative quarter, and x plus 3, and negative 3 of 4 is the x minus 1 dx. So I can evaluate each of the integral. Right? Right. That's it. So you can do that, right? You can always decompose. This is the integral. Yeah, decompose the function as a sum of the two simple terms. So now if I increase the degree of the numerator, what happens? 3. Yeah, I still use the same. I can change square minus 2 plus 2x minus 3. Let's change the sign. So here, this time, x squared. I can put anything there, right? X squared plus 2x or plus 1x, plus x. Okay. Then we cannot express as a sum of those two simple forms. Okay. So x squared plus x over x squared plus 2x minus 3. I know this can be x plus 3x minus 1. Okay, but I'm not being able to express it in that form. No way. Okay, why? The reason is the degree of the numerator this time is high. It's the same as the degree of the denominator. So you are not able to do that. The first thing you have to do is use a long division. Okay, use a long division to simplify. Okay, I put the 1 here. So I get x squared plus 2x minus 3. I take a difference. So x squared minus x squared, it's gone. X minus 2x negative x plus 3. Okay, that's my remainder. Just like you use ordinary division. Okay, so that implies this is a remainder. Okay, this is a quotient. Quotient is 1. So x squared plus x divided by x squared plus 2x minus 3 is going to be 1 plus the remainder divided by x squared plus divided by x squared plus 2x minus 3. Okay? Then the numerator is smaller. The degree of the numerator is smaller than the degree of the denominator. All right? So I can decompose the second term. Okay? So this is going to be 1 plus negative x plus 3 and x plus 3, x minus 1, right? So I can decompose it to a over x plus 3 and the b of x minus 1. Okay. Yeah. Only when the degree of the numerator is smaller than the degree of the denominator, you can do that. Right, so let's combine them. So I compare both sides. I still think I'm going to get as a plus b x and plus 3b minus a, right? So I will get a plus b equals -1. I also get -a plus 3b is going to be 3. Okay. All right. So now how do you simplify? Add them together. I get 4b equals 2. So b is going to be 1/2. Okay. Then a is going to be -b minus 1. So it's -1/2 minus 1 is -3/2. So you get the coefficient. Right, this is a and b. Okay, so now the whole function x squared plus x over x squared plus 2x minus 3 is going to be decomposed in the following form: a is -3/2, x plus 3, b is 1/2. Right? So that is what I want. Then we evaluate integral on both sides. Okay? Okay, so the integral of x squared plus x, I get the integral of x, which is x integral 1, which is x, then 3/2, then 1/2, and plus constant. Okay. Okay. Right. So yeah, I want to go back to the problem here. Is there any other way you can do it now? Right? X plus 2 over 3 minus 2x plus x squared. Okay, x plus 2. Okay, let's do this. X plus 2, x squared plus 2x minus 3. Okay, dx. You can decompose it, no problem. But I'm not going to do that. I try a different way. So x squared plus 2x minus 3 is going to be x plus 1 squared minus 4. Okay, that's what they do. Yeah. Complete and square. So it's natural to use a substitution. Let x plus 1 equals 2u, right? Okay, so dx is going to be 2 du, no problem. So the above integral is going to be here is going to be 2u squared minus 4, right? X plus 2, how can I replace by u? So x plus 2 is x plus 1 plus 1. It's 2u plus 1, okay? Yeah. X is going to be 2u minus 1. Minus 1 plus 2 is x plus. And then this is a 2 du. Okay. So after you simplify, you take 4 over 2/4 is 1/2. So it's 2u plus 1 u squared minus 1 du. Now what? I still don't want to use a decomposition, okay? I can do the following. I have 2u u squared minus 1, okay? Du, I separate. And the second one, we already know that, right? Yeah. The first one, actually, you have to use another substitution because there was a u on the top, so you can use a substitution. So you let w to be u squared minus 1, so dw equals 2u du, okay? So you will get the integral 2u du is actually dw, just w, okay? Another one, I have to put a negative sign there, right? Yeah, because I have a formula to use. This is going to be natural log of square w minus 1/2. And we already did this several times at the very beginning. So 1/2 natural log 1 plus u 1 minus. Okay, so this is the answer, but not the final answer yet, right? What is w? W is u squared minus 1. U squared minus 1 equals 1 minus u squared, doesn't matter. Okay? If you use a small, then the absolute value can be removed. Okay? We still have to go back our substitution. U is going to be half of x plus 1. So I needed to replace it. Okay? A quarter natural log 1 plus x plus 1 over 2, 1 over x plus 1 over 2. Okay, and you simplify a little bit, you can get it on. Okay. Yeah. So this is answer, okay? I did not decompose the function. I'm still able to do that. Now let's do the next problem. I changed the function a little bit. I changed it to the 3. Okay, I begin with this. Okay. Nothing on the top. Maybe just only one constant. Okay, how can I do that? I try to factor it. Does not work. It's not working. It's not good because it does not have a zeros for this. So x squared plus 2x plus 3 is going to be x squared plus 2x plus 1. Then you subtract 1, right? So you are going to get x plus 1 squared plus 2. Okay? So this is your integral. The integral becomes x plus 1 squared plus 2 dx. So my natural substitution is going to be let x plus 1 is being square root 2 times u. Okay, because when I square, I get a 2u, right? Okay, so dx equals square root 2 du. So that can be dx is square root 2 du. Okay, and I do get a 2 in the denominator. The numerator, there is a 2 also here. I can take it out. And the antiderivative of this is going to be arctangent to u, right? Okay. And what is u? U is going to be x plus 1 divided by square root 2. Okay. So to look at this problem, I cannot decompose the function. So I use the idea. I have two ideas here to evaluate the integral completing the square for the quadratic function. I then use a substitution. Or I just decompose the function rational, we call it rational function direct, right? To get a sum of two simpler terms. And then you evaluate. Okay. For simplify, I don't like the square root 2, so I'm going to change it to x squared plus 2x plus 2. Okay, make it easier. So on the top, I can have just x plus 1 or something, x plus 3, doesn't it? Right? Let's do this. So I increase the power a little bit, right? Let's just degree 1. You know, if it's x squared plus 3, then I have to use a long division to simplify. Right now, it's okay. So how can I do that? I cannot fact x squared plus 2x plus 2. So the only way I can do is going to be complete with a square, right? And then use a substitution. Okay. So I let x plus 1 here to be u. So du is equal to x. Right. So the integral becomes u squared plus 1 and dx is du. How about x plus 3? X plus 1 is u, x plus 3 is u plus 2. So it's u plus 2. Then what? It's simpler, but I cannot evaluate an antiderivative directly. So I have to separate. Okay, I separate, I get u squared plus 1. The second one, I know it's arctangent to u. The first one, I still use another substitution. I have to use a substitution. Okay, so I let w to be u squared plus 1, and the dw equals 2u du. And, okay, then you get w. U times du is going to be half of dw, right? And plus twice, and this side is arctangent to u. So I can put a solution there. So I get absolute value of u. And 2. Okay. Okay. And w is going to be u squared plus 1, so you don't need absolute value symbol. So that's still u, right? U is the x. What is u? U is the x plus 1. So you change it to x plus 1 squared. Okay, so this is done. Right. So we couple more minutes. Let's do one more problem. Right. This almost cover all the type of problems. So similarly, I get x squared plus 3 instead of x squared plus 2x plus 2, right? In this case, the degree of the numerator has a degree of same as the degree of the denominator. So you have to use a long division to simplify it. So you put the 1 here, you get an x squared plus 2x plus 2. Take subtraction, you get negative 2x, 3 minus 2, 1. So you are going to get the integral. This function is going to have a quotient plus negative 2x plus 1 and the x squared plus 2x plus 2 dx. Okay. So we are now able to decompose it, the second part, into some of those reciprocal linear functions. I can only still use a substitution. Okay. So here is going to be like an x plus 1 squared plus 1, right? Negative 2x plus 1 dx. So I let u to be x plus 1. Okay. So you get u plus u squared plus 1, negative 2. What is x? Yeah, we have to figure out what is negative 2x, right? Negative 2x plus 1 is going to be negative 2. X is u minus 1 and plus 1. So negative 2u plus 2 plus 1. So 2u plus 3. Okay. Be careful, okay? When you change dx, this should be dx separate. So this is otherwise that would be a mistake, okay? So I cannot do like that immediately. I have to put this one here and this already being x, okay? Then I can change. Then I get 2u u squared plus 1 du and plus 3 integral of u squared plus 1. To save time, I just write down the answer here. X minus natural log of u squared plus 1. And here 3 arctangent inverse, yeah, arctangent. Okay, then you replace u by x plus 1. Right, so that's the answer.